Friends, there seems to be a lot of confusion with terms like atomic weight and atomic mass, and some even say that they are one and the same. But are they the same? Let us see. Let us pick a number, say like 72. What physical quantity does this number represent? No, it does not represent any physical quantity, it is just a number. But when you add the unit kilogram next to this number, we understand that it represents the physical quantity mass. We understand that this represents temperature because of this K, and this time because of this S, and so on. So every physical quantity has some magnitude that is represented by the number and a unit next to it. So if there is no unit next to the number, it does not represent any physical quantity. So you take any branch of science, numbers are not physical quantities. A physical quantity has a number followed by a unit. In the year 1808, John Dalton figured out a way to compare masses of atoms of different elements with the mass of one hydrogen atom. And he found that one nitrogen atom is 14 times as heavier as one hydrogen atom, and an oxygen atom is 16 times as heavier as one hydrogen atom, and so on. Now, what does this number tell us? This number tells the number of times one atom of oxygen is heavier than one atom of hydrogen. Now you are all good at math. What would happen if we move this term to the left hand side? It goes into the denominator, and on the left hand side we will have this ratio, and on the right hand side we will be left with this number without anything next to it. So here we have a ratio between the mass of one atom of oxygen and mass of one hydrogen atom. And John Dalton called this ratio atomic weight. And it is equal to 16 for oxygen. And what is this 16? It tells the number of times one oxygen atom is heavier than one hydrogen atom. So atomic weight tells the number of times one atom of an element is heavier than one hydrogen atom that he took as reference to compare the masses of different atoms. And here is the interesting part. He determined atomic weights are the values of this ratio for different elements without knowing the values of the numerator and the values of the denominator separately. Don't think that he measured the mass of the oxygen atom in kilograms and that of a hydrogen atom as well in kilograms and divided one with the other. Understand that it is possible to know the value of a fraction without knowing the values of its numerator and denominator. And even today, we determine atomic weights are the values of such ratios without knowing the values of the numerator and the denominator separately. But there are two differences between the way John Dalton did it back in 1808 and the way we do it today. The first difference is John Dalton used chemical reactions or chemical methods to determine atomic weights. Today, we use mass spectrometers or physical methods to determine atomic weights or the values of such ratios. The second difference is John Dalton took the mass of one hydrogen atom as the reference to determine atomic weights, but today we use 1/12 of the mass of one atom of C12 isotope as the reference to determine atomic weights. And here is the latest definition for atomic weight of an element. It is the ratio between mass of one atom of the element and 1/12 of the mass of one atom of C12 isotope. That is our latest reference or standard for atomic weights. And in this ratio, we have the same physical quantity mass in the numerator and the denominator. So, the units of the numerator and the denominator are one and the same, so they get cancelled. So, atomic weight is a dimensionless number. Then what does it tell us? As we already discussed, it tells the number of times one atom of the element is heavier than the reference, and this is our latest reference. And remember, numbers do not represent any physical quantity. Now, what is the atomic weight of nitrogen? The answer is 14 without anything next to it, just this number. Then what does it tell us? This tells one nitrogen atom is 14 times as heavier as this reference. Similarly, the atomic weight of sodium is 23 and atomic weight of chlorine is just this number 35.5. Now let us rewrite this equation by moving this term to the left hand side. Then this is what we will have. Mass of one atom of an element will be equal to atomic weight of the element multiplied with 1/12 of the mass of one atom of C12 isotope. And what do we have here on the right hand side? We have the physical quantity mass multiplied with atomic weight, that is a number. When you multiply a physical quantity with a number, then you would get the same physical quantity. So that is what we have here on the left hand side as well. So understand that this product represents the physical quantity called mass. And we have a name for this particular amount of mass, that is one unified atomic mass unit. And the symbol for unified atomic mass unit is small u. So, mass of one atom of an element is its atomic weight multiplied with 1 u. And mass of one atom is composed of 4 words, and I am too lazy for 4 words. That is why we came up with this shorter version called atomic mass. So atomic mass is nothing but mass of one atom. Then this equation becomes atomic mass of an element is equal to its atomic weight multiplied with 1 u. So what is the atomic mass of nitrogen? Its atomic weight multiplied with 1 u. So 14 multiplied with 1 u is 14 u. Similarly, the atomic mass of sodium is 23 u and atomic mass of chlorine is 35.5 u approximately. So atomic mass represents the physical quantity called mass. It must be expressed in units of mass like u or kilograms, etc. Generally, it is expressed in unified atomic mass units. Now, what is our answer to the question, are atomic weight and atomic mass the same? The answer is no, they are not the same. Atomic weight is a dimensionless number that tells the number of times one atom of an element is heavier than the chosen reference. Whereas atomic mass, that is mass of one atom, represents the physical quantity called mass, expressed in units of mass like u or kg, etc. Before we end this video, I have one final thing to say. For a very long time, physicists did not like the name atomic weight. See, by this name, one would think that you are talking about the weight of an atom. But see what we have on the right hand side. We have a ratio between two masses. So we are referring to the ratio between two masses by atomic weight, and that is wrong. Because you know mass and weight are two different physical quantities. Mass is the amount of matter present in an object, and weight is the force experienced by that mass when placed in a gravitational field. So clearly, by atomic weight, we are not referring to the weight of an atom. and on top of that we are actually referring to a ratio. So they suggested two changes to the name atomic weight. One is replace weight with mass and add the word relative to clearly indicate that you are referring to a ratio between two masses. So atomic weight's new name is relative atomic mass. So relative atomic mass and atomic weight mean the same. So what is relative atomic mass or atomic weight of nitrogen? It is the dimensionless number 14, that is 14 without anything next to it. But what is atomic mass of nitrogen? It is its atomic weight or relative atomic mass multiplied with 1U, that is 14U. You might find these terms a little bit confusing, but trust me, you will get used to them.